Good morning from a cloudy Toronto, Canada, and welcome to another live Quanser user webinar. In this webinar series, we highlight the works of academics from around the world using Quanser solutions and technologies. My name is Arman Mulki, and together with my colleague Ariane Penna, we will be your hosts and moderator this morning. Today, we're thrilled and honored to have a great friend of Quanser, Professor Tolga Kaya from Sacred Heart University in Connecticut, to discuss how, under his leadership, smart vehicles were integrated in their undergraduate ECE curriculum.
Thanks, Armin. Hello, everyone. Thank you very much for joining us. And I know how you all are so swamped with the webinars these days due to the pandemic and working from home. But again, thank you so much for joining to Quanser's webinar. I'm Aryan, the territory manager at Quanser, and as a part of my role, I get to work with a lot of amazing professors, universities, and researchers in the US on different controls, mechatronics, robotics projects. But I have to say, this particular project that we did with Dr. Tolga Kaya, that I had the pleasure to be a part of, was very unique. And I'm very excited that today we finally get a chance to share it with you all. And I have to give a shout out to our partner in the region, AET Labs, who supported Dr. Kaya throughout this project and basically helped us to make sure that this project goes smoothly and all the parties involved are happy and satisfied. With any further ado, I'm gonna introduce Dr. Tolga Kaya that again, Quanser had the pleasure to work with on this project, and then you guys will hear all the goods and greats about this project from Dr. Kaya very soon. Dr. Tolga Kaya is currently a professor and director of electrical and computer engineering programs under the School of Computer Science and Engineering at Sacred Heart University, or SHU. Before joining to SHU in 2017, Dr. Kaya was an associate professor at Central Michigan University's School of Engineering and Technology between 2010 to 2017. Dr. Kaya worked as a research scientist at Yale University from 2007 to 2010 at the School of Engineering and Applied Science. He has worked in the industry as a technology consultant at Brightwell Corporation and a senior analog circuit designer at Microelectronics Inc. for several years. Dr. Kaya has a diverse research background and accomplishments on electrical, computer, and biomedical engineering. His research primarily focuses on wearable devices to monitor physiology of athletes. He's well known in the field of hydration research. Dr. Kaya also focuses on Internet of Things, or IoT devices, 3D printing technologies, and more recently, sports data analytics. In the past few years, Dr. Kaya also conducted research on education technology and teaching pedagogies. He implements active learning strategies in his classrooms and focuses on student-centered learning. All his courses have significant hands-on components with plenty of activities to help students link theory with practice. That's an amazing bio for Dr. Kaya, and just a fun fact about him as well, that it was not part of the program, but I want to say that Dr. Kaya also has done some triathlons as well. So no wonder why one of his expertise in the sports research. All right, I'm going to pass it to Dr. Kaya, and Tolga, thanks again for presenting today, and very excited to hear. Thanks, everyone. Enjoy.
Thank you.
All right. Well, thank you very much, Aryan, for the introduction, and thank you very much, Arman, as well. And yes, I'm getting ready for my half Ironman in July 11th. So very exciting. So let's talk about our projects. So let me go to the full screen mode. Okay, so the point that I wanted to make really is that, you know, we started with, we have no idea what we're doing, to wait, this actually makes sense. So that's what I'm going to be basically talking today, and so you can see our the progress. So I'll talk. Aryan gave a great background. I'm just going to talk a little bit about a few things about me and then our engineering programs and how we really acquired the Quanser systems, and then first our challenges, and then our successes, and then what we're going to be doing moving forward. So just a quick about me. So I was a circuit designer, so that's how I was educated and trained. And then during my PhD, I worked on micro machines, micro electromechanical systems on energy harvesting projects. And then during my postdoc years at Yale, I worked on biomedical projects with bacteria hydrodynamics. And then my research after my postdoc and when I was a faculty, it started really with the sports analytics and sports because I'm an athlete and I enjoy. So I did a lot of sweat-related research. I'm one of the experts in the field, and I also looked at the advanced materials aspects of the field. Well, so far, you can see that I have done nothing about necessarily robotics or control systems. Well, we'll see how that impacted our projects. As a teacher, like Ariane also said, so I'm really big on hands-on projects. We do a lot of project-based learning in classes and outside classes. We do a lot of outreach. So Sacred Heart University is known for its community service. So we do a lot of outreach for engineering program and also the universities, other outreach programs. So it is something that defines us. And as a director, when I came to Sacred Heart to start engineering programs here, I was really thinking about, okay, so how can we define a niche for our programs? And I was thinking, because we had computer engineering at that time, and then we were starting electrical engineering, I thought, what is like ECE, electrical and computer engineering, a platform that we can use? And then I started with drones. So on the left, you can see students are working on assembling drone frames, race drones. Those are first-person view drones. And then on the right, we actually hacked those drones and then made them hovers and made like a football game or soccer game. I'm sorry, for Europeans, and you would know like the football is the soccer. And then when we think about the engineering programs, we really looked into like where we really fit. So when we first started, we were under the college arts and sciences. So there are 5 colleges at Sacred Heart. And then while we were transitioning from starting computer engineering and starting electrical engineering, actually, we transitioned our School of Computer Science and Engineering under the College of Business, and it became College of Business and Technology. So that was an interesting change where we started thinking about more perspective of the entrepreneurship, prototyping, and dealing with systems and how it impacts with the businesses. So one thing that we were really lucky at Sacred Heart, although we have a very relatively small like a boutique program, about a total of 50 students in both programs, we have a great facility. So we call it Idea Lab, Innovate, Design, Engineer, and Apply. So this is the studio area that you see, and then we have about two basketball court size of a space with 3D printers, laser cutters, and CNC routers. And then we have a great electronics classroom where I am actually right now. So so this is the place where we actually work on all our projects. So it's a one-stop shop, and then we're lucky that we have a full-time lab manager, like a makerspace and lab managers, Cedric, who has been amazingly helpful for setting up everything for us. So let's talk about the curriculum a little bit for electrical and computer engineering. So engineering, it's no secret sauce, and it's traditional, and you have to cover like math courses and physics and all the necessary engineering courses and the capstone. So it's pretty similar. So I'm just telling you that first year we have the explorations classes. We have a core, foundational core classes at Sacred Heart. And then the second year, you start taking analog and digital electronics courses and some computational methods courses, which I'm going to talk a little bit more. And then third year is embedded systems, signals and systems. And depending on your direction, either electrical or computer engineering, could be power electronics or FPGAs, field programmable gate arrays. And in the fourth year, of course, in the capstone and lots of electives for students to specialize if they're interested in any particular field. So when we think about the platforms or the languages that we use, so we are on the School of Computer Science and Engineering, and the Sacred Heart has a much longer and stronger computer science programs, and engineering is very new. So initially it was C was the main programming language, but then we switched to Python to teach at the very beginning to our students as the main teaching platform. But of course, MATLAB takes the bigger portion of our curriculum, as you start, using like a lot of computational and then embedded systems, signals and systems, audio and signals, video processing. MATLAB starts again, our main platform. So those are our, programming languages that we use. And then we started exploring, okay, what would be the platform that we would use for students to actually use those coding and practice, and then also get some hands-on experiences. So we Elago or Illigo, or however you pronounce it, they're like a small, like a smart robot car kits. They're a little bit clunky and a lot of little issues, but we use them for a while. Of course, Arduino and Raspberry Pi are our go-to project components that we use both for Python and C, and even MATLAB that we use actually the Arduino in our MATLAB class. So when it comes to MATLAB and Simulink, we started using MATLAB. We are using MATLAB mostly in our computational methods in engineering class. That's in ENGR 200, so it's a 200 level class, a sophomore class. Usually we call it like a MATLAB class because we use Arduinos, ESP32s, other sensor integrations through MATLAB, so students can explore both hardware and software, but in a way that they can still use MATLAB. And in the signal processing class, in the like a 300 level class, now MATLAB again is in the cornerstone using like FFT or audio analysis. Students use a lot of MATLAB in there. And in the capstone, of course, a lot of data processing, a lot of data analysis and plotting. MATLAB is being used significantly. So the question here that came that we have a lot of use of MATLAB. We are trying to develop, look at platforms, what we can do, and then the question really came in a way that, do we really want to design a platform for ourselves, or use an established platform that we can actually develop the projects on it and use still these? So that was a debate, and we did develop our drones. We actually designed our own flight controllers with the PCB and then programming everything. That's actually going to be another class in our curriculum. But we were really thinking that as a standard platform that we can use for students to use, that we know it works, and then we can practice with MATLAB and different platforms. That's when Quanser really came in. So it was, for me, it was love at first sight. I saw them in a conference in 2018, and I really loved it right away. And it was timely because we were building our lab at that time. So major equipment purchases were happening. So we were lucky that it was the right time. And then I went all in. So we purchased the autonomous vehicle research studio with 4 drones, 4 ground robots, and 2 arrows. And this picture is actually the classroom where I'm sitting right now. Actually, you see one. Where I'm sitting right now is actually right in the middle. We set up everything. Arman was there, Arian was there, and Justin from AET Labs, he was there. So we set up everything. They demoed it, so everything was working perfect, and the problem was solved. So I was so excited. Everything was great. I thought, okay, this is gonna work perfect. Well, did I really solve the problem? well, we got the great system in our hands, and then we gave hugs to Arman. It wasn't pandemic at that time, and then he left, and then we were left with the system, and then the problem started. So the first problem was, well, we installed the entire system in classroom, and we need to use the classroom for classroom purposes. So and we said, you know what, there's an old makerspace area, maybe we can start using that area. So we started doing some sketches with Quanser, and then we installed the netting and then the cameras on the ceiling, and then that started working great. Until last year, when we were asked to evacuate the space because that space was going to be built for something else. So now we're back to the classroom again in this space, and now we're putting those cameras in the ceiling again, and then areas getting a little bit cramped. We are actually we just got our the Q car, the smart car, the system from Quanser as well, and we are installing the smart city that I call it, in the same space. So it's getting a little bit cramped, but well, we know in engineering, when you have like a cramped and when you have tight in spaces, that's when creativity comes. So we are actually working out, and it looks like it's going to work great, and everything is going to be in one space. And then you can see even in my back, the students actually working on the Quanser systems. We actually are now getting ready for the semester. So another challenge, which was a huge challenge, was the inertia. I mean, literally the inertia. So we didn't have any know-how. So when Arman was here, everything was great. Whatever he was saying, it made sense to everybody. And then once he left, everybody was looking at each other. Me and other faculty members and students. Students had just started learning MATLAB. They had no experience with Simulink. I used Simulink maybe 20 years ago, and it was a lot of lack of experience in the group, and also never underestimate the presence of upperclassmen. Well, we didn't have that. So we had very like a young group of students who were just starting to get going. So that was a big issue. So the system, we were not able to really utilize the system, not even start getting going. So that was a big issue. And that's when Quanser actually stepped in. So this is one of the screenshots from one of the Zoom sessions. This is relatively recent. So Arman and Gilbert and John from Quanser are actually helping Michael and Caitlin on mapping ground robots mapping and localization. So we started working with Quanser again to do some troubleshooting and like a technical consultation. But it was still not really enough, like here and there. And then what we developed is that, okay, let's go all in and then develop a workshop program. So Quanser was really, again, willing to help with us. So we work with Quanser engineers, and then set up some 2-hour workshop sessions that took maybe a couple months. So we had almost 10 workshop sessions. And then once we were having these workshops, we started thinking, what if actually we make this into some sort of like a certificate program? So university has a relationship with Credly for certifications. So we set these up, and Quanser was willing to, well, they allowed us to give certification, Quanser certification. So we created these certifications, like control systems, Quanser Aero, Qbot, and then in general real-time control, Quanser Simulink system. So on the bottom left, you see the Quanser Aero. It's like a half quadcopter. And on the right bottom is the Qbot, which is technically a kind of a Roomba. And I always get teased by my other colleagues. They say, so you have a Roomba, but it does everything except cleaning. So that's correct. It really helps us with a lot of processes. So now we set up these certifications, and then students actually can get these certifications and put it on their LinkedIn, put in their resume. So it's pretty good. In fact, one of the students from a Fairfield resident in Connecticut, but goes to another university in Maryland, he also attended these the workshops, and then he got his certificate. What we did even further is that so we use Blackboard as our classroom management system, and we created a organization in the Blackboard. So that is not a class; it's still like it operates like a class in terms of the workflow, but it is actually just we can add students into that, and then we created these Quanser Basics, Quanser Aero, Quanser Qbot, a lot of content under it. So Quanser has great course content on their website. But it might get a little bit overwhelming if you especially have no idea what you're doing at the beginning. So this gives us a really step-by-step, do first MATLAB on-ramp and Simulink on-ramp from MathWorks, from MATLAB, to get an understanding of MATLAB and Simulink, and then go into Quanser Aero system, learn how to operate the system, learn a few blocks, how Quark works, Quanser's software that interfaces with Simulink for real-time control. And then we are now adding some quizzes and also videos from our end. So it almost self-paced learning for students. And then we're releasing this so students can do this and get the certificate by uploading a video of their understanding. So another success that we had with the Quanser system is that we developed a capstone project. So we're trying to do capstone projects with industry. So one of the industry project was with Quanser, and two of our our first senior computer engineering students, Gabriel and Elijah, they worked on aerial vehicle vision and sensor guided landing. So they use the Q drone to recognize an April tag and the land on the particular place. So we worked on this project and we published a international conference paper on this. So that was very exciting. It was a great experience for students, and students presented the paper in a virtual conference. So it was a great experience for students and for all of us. So right now we have a research team in the Quanser research team, and the research team they work on mostly right now ground robots, and eventually they will shift gears to the research studio, both for the cars and also the drones. So you can see like green circles. So we have 4 ground robots. And then we call them, I guess now, Teenage Mutant Ninja Turtles. So one on the right is Michelangelo, and the left is Raphael, I believe. So I have 2 quick videos for you, 10-second videos from 2 students of what they're doing.
Lab using Simulink.
So that was Michael, who is actually sitting right behind me. And then I'll have Caitlin here.
I'm currently integrating the temperature sensor over PuTTY, sending the data over TCP, and reading it in Simulink using Quark.
So I'm proud of both of them. So they learned a lot in this project. They are actually our engineering interns this summer. So most of the language that they're using right now in these videos, actually they had no idea when they first started, and that they are really developing and getting significant experience in this. So I also asked these students, so we have about 5-6 students who went through this program, their experience on Quanser systems and what does Quanser system mean to them. So of course, they talked about Quanser, a lot of learning, a lot of challenge. They talk about drones, Simulink. But if you see, like, there's like a block. So they talk about block, and I was saying, what is this block? What do they mean with block? They meant Simulink, because Simulink, they associate Simulink with block coding. So that was interesting. So I didn't know that that's how they refer to it. So that's actually great, because we don't actually teach Simulink much in our curriculum. Well, now we're going to be teaching, so that's going to be interesting. So I just wanted to, as I'm slowly wrapping up, so I just wanted to tell you again, our structure with analog digital electronics and computational methods, and then you will see that computational methods class, that will have more and more Quanser in it. Right now, what we're doing with the Quanser project in the summer, we're really working with the Raspberry Pi that's on the ground robot, and then we're adding more sensors to it, and then reading the information with Python, bringing it to MATLAB, analyzing it, and then so we are really incorporating Python and MATLAB in a system that we know it works for sure. And also now we don't have to worry about the Lego or like a Raspberry Pi, individual standalone Raspberry Pi or Arduino. We are able to put things into these systems, so we can actually move forward with an established system, but add to it and then also develop it as a teaching platform. Again, we are electrical and computer engineering. We are not going to be launching the next rocket to the Mars. We are not there. So we are in the basic steps, and for us, teaching is more important in terms of using this system rather than research. So if you can publish conference papers every year in an international conference, that is a great success. If you can sustain that, we are very happy with that. And I think students are learning and having fun. So that is what we want to do. And again, the one last thing, okay, moving forward. So this is going to be our structure in terms of Quanser. The sophomore students, after they're done with their first year, they're going to be part of they are going to be invited to become a part of the research team for Quanser. So they will get the certificates, they will start using the system, develop some simple projects. And then when it comes to junior year, they will actually take a class. It's a required class with directed research in engineering. It's not an elective, it's a required class. It's a spring semester class, and they will work on a Quanser system again, do a research with that system. Maybe it's going to be image processing, maybe it's going to be mapping, localization, maybe adding more sensors and electronics. It depends on where the students are. And in the senior year, students will be doing a capstone project. So you can see the students will be actually introduced to the system as early as a sophomore year, and then when they come to the senior year, they will have a lot of information, and then they'll be able to develop more sophisticated systems. So with that, thank you very much for attending and listening this presentation. So this is my contact information. Feel free to email me anytime or find me on LinkedIn. So the video on the right side is we had like an LED wall, and then students basically use the image processing aspect of the Q-drone to basically see like how the lights are moving. Again, thank you very much for listening.
Thank you so much, Tolga. That was a great presentation, and personally, it's been a pleasure working with you, your colleagues, and your students. And all of us here at Quanser look forward to continued relationship. I have a number of questions that have come in, and by the way, this is a great time. If you do have any questions for Dr. Tolga, please type them in the questions pane, and we will get to as many as we can today. First question, one of the attendees is asking, if you were to start from all over with the Quanser system, how would you approach the problems differently?
Yeah, thank you, Arman. So it is. So we learned a lot during the process, but I think if you were to start from beginning, I would definitely develop create a group from the very beginning, and then have these training and workshops right from the beginning with Quanser, and learn the system, learn the fundamentals of Simulink and how Quark really works, rather than how the big system works. And then I would definitely start with the Quanser Aero, we started with the Q drones, and we were overwhelmed with a lot of the communication protocols and networking issues. I think the Aero would have been much better to start with to learn. So I would stagger the learning between Aero and then ground robots, the 2D system, then go to the 3D system, and of course with the smart car coming, that would be another set. But I would start with developing the knowledge and getting like a step by step rather than jumping all the way to what is really more exciting.
Thank you, Tolga. Next question. You currently don't have any mechanical or aerospace engineering programs. How do you envision involving ECE students more in the Quanser system?
Yeah, so when we look at the Quanser system, and then if you look at it, it's all about control systems, mechanical engineering, aerospace engineering, and those are great. And will we have mechanical engineering? Maybe. Aerospace engineering? Probably not. But I do believe the Quanser system it really offers not just the control systems, but at the same time a lot of electronics components. So like the students are now working on embedding like a light sensor to the ground robot to get a light a heat map of of rooms. So that is pure electronics in that sense. And with the hardware and software integration, I think we will be able to use the system significantly, and also give students more control experience and systems level thinking, which is really important for both electrical and computer engineering as a systems engineering. So we might not be able to go into very detail in like a mechanical engineering aspects, but I think with the electronics and the programming aspects, we'll really be able to utilize the system.
A very short question, and the attendee is asking, here's a tough question, MATLAB or Python?
Yeah, so I started my career with Fortran and then C. So I've never really touched Python for a long time, and I speak MATLAB. So I always thought like MATLAB is the language, but then Sacred Heart, when we switched to like a Python, I had to start getting familiar with Python. So Python really gives us a great experience, and with the Raspberry Pi and then with the scripting, so it's really easy to get going. But we also know that in the MATLAB is the system for systems level and simulations and then hardware integration. So I think probably Quanser also recognized this, and then we are actually able to use MATLAB and Python together with a lot of projects. So my question is now, well, it has to be both.
Yes, absolutely. And one final question. Where do you see SHU Engineering's Quanser platform usage in the next 5 years?
Yeah, so right now we are really getting into more into the drones and then the eventual smart cars. So we will probably next few years will be more like an understanding the systems, and then developing simple projects. But eventually, I would like to be able to utilize more going into like image processing, the computer vision, and bringing artificial intelligence and machine learning into the program. And develop it with Quanser systems. So to go to like autonomous and smart vehicle systems with our systems that we have. So I really want to go into like artificial intelligence side without losing our electronics and hardware components.
Thank you, Tolga. Actually, one more question that has come in, and I should be able to answer this. The individual is asking, it's saying, well, thank you for the presentation. It was a fantastic one. And do you, can you get the standard lab assignments and tutorials for the Quanser products? Yes, if you go visit our website at www.quanser.com, all of the courseware that we provide along with our hardware is available to be downloaded free of charge from the website. Well, this brings us to the end of our webinar. Once again, thank you, Dr. Tolga, for your time. It was an amazing presentation, and a very big thank you to everyone who attended today. I recommend that you visit our website at www.quanser.com to find out more about our numerous research validation platforms, as well as teaching products, as well as upcoming webinars. And have a wonderful day, everyone, and please stay safe.
Thank you.